In this video, I'll be going over lesson 5.1, centroid of a plane area, going over how to locate the centroid of the plane in the first example, and in the second example, I will be going over the same problem but with the addition of a substitution. So here's our problem. We've got this trapezoid shape with the distance here of 12 to the first point and then 21 inches to the second point and a height of 20 inches. We are to find the centroid of the x and the centroid of the y. Here is the equation that we will use to find it. The sum of the x times the area divided by the sum of the area. And then for the y centroid, the sum of the y location times area divided by the sum of area. I've already set up our chart that we will be using. The first section is for the shape. So there's a couple of ways you could solve this problem. The easiest one that I'll be using is to divide this trapezoid into two shapes with a triangle here and the rectangle here. Go ahead and draw that line now. Another way that you could solve this is by finding the full rectangle and then subtracting this little triangle shape here. But we'll go ahead and get into just the standard addition of the two. So I'll write here rectangle for our shape 1 and triangle for our shape 2. So we'll find the area of each for now. So your area for your rectangle is base times height, so 21 times 20 will give us 420 inches. And I did write it here what the unit is, but I'll go ahead and include it in the box since there's enough space. And for a triangle, that is base times height divided by 2, so that'll be 12 times 20 divided by 2. So for that, it will be 120 inches squared. Next will be the location of our x. So for the rectangle, let's do triangle first. It'll be here, estimately, or approximately. So to find it from the base for your x, you're going to want to do 2/3 times the distance of the x. That'll be 2/3 times 12, which gives you 8 inches. For the rectangle, it'll be in the center. So from the x, it'll be 21 divided by 2. But since you are coming from your datum point of over here, you do have to include the triangle distance. So it'll be 21 divided by 2 plus the 12. So from that, you'll get 22.5 inches. And then for this next column, we're going to just multiply our distance from the x times the area, which gives us 9,450 inches cubed. Same thing for the triangle, 8 times 120 gives us 960. Alright, and then we'll do the same thing for the y's. So for the triangle, since I did that one first last, I'll go ahead and do it first again for this. So this one is just going to be with this height. So since you're going from the bottom, you can just do 1/3 times 20, which gives us 6.67 inches. And for the rectangle, it'll be from the y distance, so going up, that'll just be 10 inches. And then once again, we'll multiply our y times our a way over here. So 10 times 420 will be 4,200 inches. Oops, inches cubed. And same thing, 6.67 times 120 will give us 800 inches cubed. And now for our third row is for the summations. So we're just going to add our areas together, which will be 540 inches squared. And for our for the product of our a and x, that'll be 10,410 inches cubed. And same thing for our y and area, that'll be So now to solve the centroid of each, you'll do your x. And so going back to our equation, we're going to get this number right here, 10,410 inches cubed, divided by our area, which our summation of our area, which is 540 inches squared, which equals, so these inches disappear and that 3 kind of goes away. And once you solve for that, it'll be 19,278 inches. And then for our y centroid, focus that, same thing, get this number, or 5,000 inches squared, cubed, divided by our 540 again, equals 9,259 inches, because once again, oops, it does cancel. And so, these are decimals, by the way. That is how you find the centroid. That is the question, as the answer to the question that was being asked, is just to find the centroid of each. And then now I will show you how to do it with a substitution. So now we will be doing the same exact problem with the same exact dimensions, but now I've added a circle in here that will need to be subtracted from the total area because it is a voided object. So in the last example, we found that our centroid was, for the x, it was 19.28. So that would approximately be, for the total shape, kind of like in this area. And then for the y, it was a little under halfway. So that kind of, as a visual, with the heavier being at the bottom, and it being less at the top, on the x direction, kind of, makes sense that that's where your centroid would be. So now with the circle to be voided, you'll see how the area shifts with there being an empty space right here. So I went ahead and copied over our graph from previously, but as you'll see, I've added the new row for a circle. So for your circle, you want to do the same exact steps in finding the area, which is pi r squared. So that would be, and for the new dimensions, I've got the radius of 5. From the y-axis, it'll be 10 inches up or down, either way you look at it, since it's 20. And then from this, I've got it going 8 inches from this line. So for your area, it'll be pi r squared, so that'll be 78.5 inches squared. And then for your x distance, this would be, so we've got 8 here, so it'll actually be from, since this is our datum point, from this x, so it'll be the 21 plus 12 minus 8. So that distance would be 25 inches. And then multiply these together for your a times x, which should be 1,962.5 inches cubed. For your y, just from the y-axis up, so that'll be another 10 here. And then your y times a, so 10 times 78.5 is 785 inches cubed. Now, since this is a circle that is a void, we'll actually have to subtract it. So this area actually will be negative. This will be positive still, since it's just a distance. But then, so you've got the positive distance times the negative area, so this will also be subtracted. Distance is still positive, but your positive times the negative area will make this also negative. So now to find our summations, you'll just add 420 plus 120 minus the 78.5 gives you a total of 461.5. Summation of this column would be 8,447.5 inches cubed. And then for your y column will be 4,215 inches cubed. And so to find your centroid again, it'll be your x bar equals your product of here divided by your area, 461.5. Don't forget your units. So this across, which gives you 18.3 inches. Same thing for our y bar. It will be this product here, 4,215 divided by area, 1.5 inches cubed, inches squared, these across equals 9.13 inches. So that, going back, would be 18, which should be a little bit over here now, and then a little under the y for your centroid location. And so now you can see the difference of having the circle or the void, any shape, would kind of change the location of your centroid of the area of this new shaded region. And just to kind of give you the overview of everything, you can kind of see where I've got my different kind of guess of where the new centroid is related to each other.